Today's topic is DC network analysis. Actually, DC network analysis depends on three basic laws, which are Ohm's law, whose mathematical expression is V, voltage, is directly proportional to I, current, or V equals to IR, where R is the proportionality constant and termed as resistance of electrical circuit. Secondly, Kirchhoff's current law, that is KCL. KCL states that the algebraic sum of all current entering a node is equal to the algebraic sum of all current leaving the node is, so that I1 plus I2 equals to I3 plus I4. That means the algebraic sum of entering the current, algebraic sum of current entering the node is equal to the algebraic sum of current leaving that node. And thirdly, Kirchhoff's voltage law, that is KVL. And KVL states that the algebraic sum of all the sources present in a network is equal to the algebraic sum of all the drops present at that network. Here Vs is the source voltage and V1 and V2 is the drops. So from KVL we can write the mathematical expression as algebraic sum of all source voltages is equal to the algebraic sum of all drop, that is Vs equals to V1 plus V2. Now I am going to some analysis which are the application of these laws. So first of all, I have taken nodal analysis. This is the application of KCL. First, I have taken a simple circuit which have three branches, one 10-volt voltage sources and one 2 ampere current sources. Here I have to find the current I0 which is flowing through the 3 ohm resistances. The 3 ohm resistance is connected between the node A and ground which has 0 volt. So applying KCL at node A, we get if the potential at node A is V, then the KCL equations will be, suppose I1 is flowing from 10 volt source to node A, I0 is flowing from node A to ground 0, and I2 is flowing from the current source to node A. So KCL equations will be I1 plus I2 equals to I0. Here I1 and I2 are the entering current at the node. So algebraic sum of all entering current is equal to the algebraic sum of all leaving current. Here the leaving current is only I0. Now I1 is equals to the if as the I1 is flowing from the 10 volt source to node A, that means we can say that the 10 volt potential is greater than the potential of node A. So I1 is equals to 10 minus V by 1, and I2 is the source current, as 2 ohm resistance is in series with current source, so I2 is also will be 2 ampere, and I0 will be the I0 is the flowing through the 3 ohm resistance. So here the potential difference means the voltage at the node A and the voltage at the ground, difference between that. So voltage at node A is V volt and ground 0 by 3, that is V by 3 ampere. So the equations will be 10 minus V by 1 plus 2 equals to V by 3, or V equals to 9 volt. So I0 equal to 9 minus 0 by 3, so 3 ampere. This is the nodal analysis method. Now I am going to another analysis, which is mesh or loop analysis. For finding mesh or loop current. Here we have also taken a simple circuit. Two sources are there. One is 10 volt voltage source and 5 volt voltage sources. 3 resistance, 1 ohm, 2 ohm and 3 ohm. Here we have to find the loop currents I1 and I2. This is the application of KVL. This is loop 1 and this is loop 2. For finding KVL equation at loop 1, first denote, I have given denotation the resistance as per direction of flowing of current. So as per my denotation, the current is entering through the positive sign and leaving through the negative sign from the 1 ohm resistance and also from the 3 ohm resistance, and the current is entering from the negative sign and leaving from the positive sign. So the algebraic sum of that drops and source is not same. The algebraic summation will be the difference. So the algebraic sum, if I have written here, actually minus 10 plus I1 into 1 ohm plus I1 minus I2 into 3 ohm. This is the actually through the 3 ohm resistance, the differential current of the two loop current is flowing through the 3 ohm resistance. That's why I have taken I1 minus I2. Why I1 minus I2? Why not I2 minus I1? Actually, when we are considering loop 1, then we have to take in the current I1 which is flowing through the loop 1 is greater than the current I2 which is flowing through the loop 2. So that your algebraic equation will be correct. This is the equation number 1. And from loop 2, the KVL equation will be, here I have give some denotation as per current direction, plus minus. So here we have seen that the current is entering the resistance through plus signs and leaving through minus sign, that is negative signs, and entering through to the source through plus signs and leaving through minus signs. So the equation will be 3 into I2 minus I1, as here we are considering the loop 2, that's why I2 current is greater than the value of I1. We should take that so that your algebraic equation will be correct. Plus 2 I2 plus 5 equals to 0. These are two KVL equations. After solving these equations, we get I1 equals to 3.18 ampere and I2 equals to 0.91 ampere. If you have any doubt regarding these solutions, you can ask. Don't hesitate. And friends, don't forget to like and subscribe the channel if this is helpful to you.